Okay guys, today we're going to talk about special right triangles. This is lesson 8-2. Our first type of special right triangle is a 45-45-90 triangle. The 45-45-90 triangle has two angles that are both 45 degrees, which means that these two angles are both congruent, which then makes both of these two sides, which are called the legs, congruent. The other side that's across from the 90 is of course called the hypotenuse. We should know that by now. When we start talking about measurements, there's an easy way to find the measurements. The leg, we will call it x. The hypotenuse is the leg x times the square root of 2. Okay, I have a different way that I teach you all to find them. I show using proportions. So I know that these two legs are congruent, which means that if I do it in terms of one unit long for each side, that on the inside I have the measurements of 1, 1, and the square root of 2. I then set up using proportions of inside measurement over outside measurement equal to the other inside measurement over the other outside measurement of what I'm looking for. So let's look at some examples. Example 1. I first write in my 1, 1, square root 2. The 1 and the 1 are on the two sides that touch the 90. The square root of 2 is on the hypotenuse. So if I wanted to find x using the proportion inside over outside, I'd work out 1 over x equals 1 over 8 using the side that I know both the inside and outside measurement. And then if I cross multiply, I get that x equals 8. So x is 8. To find y, set up the same thing. So inside over outside is square root of 2 over y equals inside over outside of the one that I know is 1 over 8. Cross multiply, I get that y equals 8 times the radical 2, or 8 square roots of 2. Okay, I'm going to work on the odds today. You will have the evens posted. If I go on to number 3, again I write in the 1, 1, square root 2, set up inside over outside, and one thing that I do know is that x and y will be the exact same. So if I find one of them, I find them both. So 1 over x equals 9, or square root of 2 over 19. Cross multiply, I get that x times the square root of 2 equals 19. I got to get rid of the square root of 2, so I'm going to divide everything by square root 2. So I've got that x equals 19 divided by square root 2. I cannot leave a radical in the bottom, so I'm going to multiply by the square root of 2. Top and bottom. So I actually get that x is 19 radical 2 over 2. Same for y because those two are congruent. 19 radical 2 over 2. Okay, let's go ahead and look at our next form of special right triangles. My next type of special right triangle is called a 30-60-90. 30-60-90 triangle has three different angle measurements. It has a 30, a 60, and a 90. The short leg is across from the smallest angle, so it's across from the 30. The longer leg is across from the 60, and the hypotenuse, of course, is across from the 90. If we do the same terms as what we did before, we're going to call the short leg x. So if the short leg is x, the long leg has the measurement of x times the square root of 3, and the hypotenuse has the measurement of 2 times x. Okay, we'll keep moving. I again use proportions. So on the inside where x was, I'm going to put a 1. Then I need to find the hypotenuse, which is going to be 2, and the long leg is going to be times the square root of 3. So this one counts 1, 2, square root 3. So if I work these, I'm going to go ahead and work the even examples here, 4 and 6. So I write on the inside 1, 2, square root 3, making sure I put them in the correct position of short leg, hypotenuse, long leg. And then I set up the proportions as I did before. So for x, I'd have inside square root of 3 over outside x equals the one that I know both inside and outside, 1 over 5. Then I cross multiply and I get that x equals 5 radical 3. For y, I do the same thing. So I've got inside over outside, 2 over y equals the one that I know inside and outside, 1 over 5. Cross multiply and I get that y equals 10. I'm going to go ahead and look at number 5 also. So again, across from the 30 is my 1. My 2 is on the hypotenuse. My square root of 3 is on the long leg. To find x, inside over outside, I do 2 over x equals 1 over 14. Cross multiply, I get that x equals 28. So x is 28 here. To find y, inside over outside, so I've got square root of 3 over y equals 1 over 14. I cross multiply and I get that y equals 14 radical 3. Again on number 6, 1 on the short side, 2 on the hypotenuse, square root of 3 on the long. So to find x, I'd do 1 over x equals 2 over 32. So I'd have 2x equals 32. If I divide it all by 2, I get that x equals 16. To find y, same thing, square root of 3 over y equals 2 over 32. If I cross multiply, I have that 2y equals 32 radical 3. And then if I divide everything by 2, I get that y is 32 divided by 2 is 16 radical 3. Okay, let's keep moving. Number 7. Here's my 30-degree angle. So across from it is 1. On the hypotenuse is 2. The long leg is square root of 3. So if I want to find the long leg here, so I'm going to use square root of 3 over x equals 2 over 46. Cross multiply, I've got 2x equals 46 radical 3. Divide everything by 2. I've got that x is 23 radical 3. If I want to find y, I've got 1 over y equals 2 over 46. So in other words, I've got that 2y equals 46. Divide everything by 2, I've got that y equals 23. Number 8, again the 30's up here. If I don't see the 30, I want to write it in. So my sides, short side's 1, hypotenuse is 2, long side square root of 3. And then start setting up my proportions. So to find x, I've got 2 over x equals square root of 3 over 20. I'm going to cross multiply, and I've got that x radical 3 equals 40. Then divide everything by radical 3. So I've actually got that x is 40 divided by radical 3. I can't leave a radical in the bottom, so I'm going to multiply by square root of 3 over square root of 3. I get that x is 40 radical 3 divided by 3. To find y, I'm going to do 1 over y equals radical 3 over 20. So I've actually got that y radical 3 equals 20. Divide everything by radical 3. So I've got y equals 20 divided by radical 3. Can't leave that radical in the bottom, so I'm going to multiply by radical 3 over radical 3. So I get that y is 20 radical 3 over 3. If I work problem 9, again, across from the 30 is 1, the hypotenuse is 2, the long side is radical 3. So now, to find x, 1 over x equals radical 3 over 9 radical 3. So I've got x radical 3 equals 9 radical 3. If I divide both sides by that radical 3, I get that x equals 9. To find y, 2 over y equals radical 3 over 9 radical 3. So y radical 3 equals 18 radical 3. Divide both sides by radical 3. I get that y is 18. Okay, as I keep going, we're going to start mixing it up with some of the odd problems. These will be mixed practice. So there will be some 45, 45, 90s. There will be some 30, 60, 90s. There will be some that have both. So this one would be a 30, 60, 90. So that means across from the 30 is 1. On the hypotenuse is 2. The long side is radical 3. To find x, I'm going to take radical 3 over x equals 2 over 16. So I've actually got 2x equals 16 radical 3. Then if I divide it all by 2, I get that x is 8 radical 3. To find y, 1 over y is 2 over 16. So I've actually got 2y equals 16. Divide everything by 2, y is 8. So I have that x is 8 radical 3, y is 8. Keep moving forward. Number 13, 30, 60, 90 again. So I've got 1, 2, radical 3. So to find x, it'd be radical 3 over x equals 1 over 11. So I get that x is 11 radical 3. To find y, 2 over y equals 1 over 11. Cross multiply. I've got that y equals 22. Keep moving forward. Example 15. This is a 45, 45, 90. So this one I only have the two different measurements. I have the two legs are both 1, and I have that the hypotenuse is radical 2. So to find x, I'd do 1 over x equals radical 2 over 9 radical 2. So I've got x radical 2 equals 9 radical 2. And if I divide by the radical 2, I get that x equals 9. Now, on the 45, 45, 90, I know that the two legs are equal, so y also has to equal 9. We'll keep moving forward. Number 17, again, a 45, 45, 90. So I've got 1, 1, radical 2. X and y are going to be the same measurement, so I'm going to do 1 over x equals radical 2 over radical 10. So cross multiply, I've got x radical 2 equals radical 10. I'm going to divide both sides by radical 2. Whenever I divide, I can divide underneath the radical sign. So I can take radical 10 and divide it by radical 2. 10 divided by 2 is radical 5. So x and y here will both be radical 5. Keep moving forward. Problem 19 combines both a 45, 45, 90 and a 30, 60, 90. So on the 30, 60, 90, I know that my measurements are 1, 2, square root 3. On the 45, 45, 90, I know that they are 1, 1, square root 2. Okay, so I'm going to focus on z first because I see that I could find it pretty quickly by doing 1 over 9 equals 2 over z. And so then I would get that z equals 18. Now, to find x and y, the first thing I'm going to have to do is find the hypotenuse of that 45, 45, 90 triangle. So I'm going to call this a, just so that I've got some other variable than what I'm looking for. So if I work to find a, I have 1 over 9 equals radical 3, because I'm dealing with a 30, 60, 90, over a. I cross multiply and I get that a equals 9 radical 3. So that means that this piece I'm going to draw it out here, is 9 radical 3. So then to find x and y, first thing I know is those two are congruent. So I can do 1 over x equals, now that I'm dealing with the 45, 45, 90, I use the measurement on the inside, so square root of 2 over 9 radical 3. Whenever I cross multiply, I get x radical 2 equals 9 radical 3. I have to divide both sides by radical 2. So I get that x is 9 radical 3 divided by radical 2. I can't leave the radical in the denominator, so I'm going to multiply top and bottom by radical 2. So I get that x is 9, I multiply underneath the radicals, 6 divided by 2. 9 does not divide evenly by 2, so my final answer is x and y are both 9 radical 6 divided by 2. Keep moving forward. Number 21 again combines the 30, 60, 90 and the 45, 45, 90. So on the 45, 45, 90 I have measurements of 1, 1, radical 2. And I'm going to switch colors here. On the 30, 60, 90 I've got 1, 2, radical 3. So I think I'm going to have to start with the 30, 60, 90 and find its measurements. I'm going to switch to a little lighter blue here. So for the x, I'd do 1 over x equals 2 over 12. Cross multiply and I'd have 2x equals 12. Divide everything by the 2 and I'd get that x equals 6. So I found my x. Now I need to find that piece that combines them both. Let's call it h this time. So if I want to find h and I'm dealing with the 30, 60, 90, I would do square root of 3 over h equals 2 over 12. So then whenever I cross multiply, I have 2h equals 12 radical 3. And if I divide everything by 2, I get that h is 6 radical 3. So that tells me this length is 6 radical 3, which is going to be the same measurement as y because those sides are exactly the same. So y is 6 radical 3. For side z, I'm going to use the 45, 45, 90. So I have radical 2 over z equals, it's going to be 1 over 6 radical 3. So I have that z equals, multiply the numbers on the outside, that's 6, multiply the numbers underneath, that's 6. So z is 6 radical 6. Next example. Example 23. Again, it combines the two types of triangles. So on the 30, 60, 90, I have 1, 2, radical 3. On the 45, 45, 90, I have 1, 1, radical 2. Since this side is 1 and it matches side z, I could also call this z long. So now, sorry guys, if I want to find z, I can do 1 over z equals radical 2 over 15 radical 2, which gives me z radical 2 equals 15 radical 2. Divide both sides by radical 2 and I get that z is equal to 15. So that means that this side length is 15. So now if I wanted to find x, I could do 2 over x equals radical 3 over 15. So I'd actually have x radical 3 equals 30. I'd divide everything by radical 3 and I would get that x is 30 divided by radical 3. I'd multiply top and bottom by radical 3 and I'd get 30 radical 3 over 3. Then if I go ahead and divide 30 by 3, I get that x is equal to 10 radical 3. To find y, I'm going to use the same method. 1 over y equals radical 3 over 15. So I have y radical 3 equals 15. I'm going to divide everything by radical 3. So I get that y is 15 divided by radical 3. I can't leave that radical in the bottom, so I multiply by radical 3 over radical 3, which gives me 15 radical 3 over 3. And I can divide 15 by 3 evenly, so it is 5 radical 3 for y. That ends our discussion of special right triangles. I will post the full answers for the notes on your Canvas course.